we have to make a decision. Now, I haven't told you how to make the decision yet, but I'm going to tell you this: you have to make a decision. And as with any decision-making process, the decision that is made is only going to be one of two ways. You're either going to make a correct decision or you're going to make an oops. There's no two ways around it. There's no third alternative. Okay? You either make the correct decision or you make an incorrect decision. Now remember, with hypothesis testing, we state the null hypothesis and we state the alternative hypothesis. And in hypothesis testing, I'll probably state this again many times throughout the night, we always assume, we have to start somewhere, so we assume that the null hypothesis is true. You need a starting place to do this, so we assume that the null hypothesis is true. Keep that in mind. So if you assume that the null hypothesis is true, then if you make a correct decision, then that means that you are going to fail to reject the null hypothesis when the null hypothesis is true. So if you fail to reject the null hypothesis when the null hypothesis is true, you've made a correct decision. I hope that's pretty clear. The second thing you can do is you can reject the null in favor of the alternative hypothesis. And when you reject the null hypothesis in favor of the alternative hypothesis, and the alternative hypothesis is true, guess what? Go ahead, guess. You made a correct decision. Bingo. I mean, it's right there on the slide. Can't miss it. But if you fail to reject the null hypothesis when the null hypothesis is false, that is, you don't move from the null hypothesis to the alternative hypothesis, and the alternative hypothesis is the true hypothesis, then you made an oops. You failed to reject when you should have rejected. So you've made an error. You should have changed your mind. Okay? Or, if you accept the alternative when the alternative is false, that is, you reject the null in favor of the alternative, but the alternative hypothesis is not true or is incorrect, guess what? You made an oops. So you're either going to make a correct decision or you're going to make an incorrect decision. If you make a correct decision, there's nothing to talk about. You're good to go. You make an oops, we need to go a little bit further. So now let's take a look at our oopses, because we can make some oopses. So the first oops is called a type 1 error. A type 1 error occurs if one rejects the null hypothesis when it is true. And I'm going to be a little bit picky on my language, so you'll probably hear me state some things that are a little bit different than on my slides, and I'll explain why. So a type 1 error occurs if the null hypothesis is rejected when in fact the null hypothesis is true. Remember, I stated that we have our null up top and our alternative on bottom. So we assume the null is true. If you come back and say, we're going to use the alternative hypothesis, I'm rejecting the null in favor of the alternative, but the null is true, you've made an oops, and we call that a type 1 error. Please note that the probability of committing the type 1 error is denoted by alpha. Sound familiar? Look familiar? I believe in your project proposal, I asked you to choose an alpha level. So alpha is the probability of committing a type 1 error. Please note that alpha is the probability of committing the type 1 error. The type 1 error is the error you commit when you reject the null in favor of the alternative when the null is true. Please keep the type 1 error and its probability separate. So that alpha level that I asked you to pick is exactly what we're seeing on this slide right now. The other type of error that you can commit is called a type 2 error. A type 2 error is when you fail to reject the null hypothesis when the alternative is true. The probability of committing a type 2 error is denoted by the Greek letter beta. So beta is the probability of committing the type 2 error. So that is the probability, and I don't like this word except, it's failing to reject the null when the null is false. Or another way of viewing this, it's the probability of failing to reject the null when the alternative is true. So the type 2 error occurs when you fail to reject the null when the alternative is true. And its probability is beta, is denoted by beta. Are we good so far? Because my next slide I'm going to pull everything together. Pull everything together. All right, so here's the fun part, and then I'm going to throw something at you that's going to rock your world. And if you don't think it will when I make this statement, I will be surprised. So when we're performing our hypothesis testing, there's two things that are under consideration. One is the decision that you're going to make based off of your data, and second is the true state of nature. Ooh. Here's the fun part. You will never know the true state of nature. You will never, ever know the true state of nature. Ever. So here's the fun part. You make a decision to fail to reject the null hypothesis, its true state of nature is true, then you've made a correct decision. Here's the fun part. You don't know if you actually made a correct decision or not with 100% certainty. Or if you reject the null hypothesis in favor of the alternative, when the alternative is true, then you've made your correct decision. But here's the interesting thing. Since you never know the true state of nature, you never know if you really made the correct decision or not. But if you reject the null hypothesis in favor of the alternative, when the null is true, then you've made an oops. An error. So the only way you can know the true state of nature is if the Almighty comes down and says, oh, by the way, the alternative is actually true, and you accepted the null hypothesis, then you know that you've committed this type 2 error. All right? So this is where the things, now if that didn't rock your world, then I don't know. Then you're pretty solid. But this is usually pretty fun stuff right here when you start to think about it. You never know the true state of nature. So you're making these decisions, and that's why probability is going to play into this account, okay? So let's get into that component here. So I want to ask you a rhetorical question before I move on. If you were to make an error in your decision-making process, if you make an error, whether you intentionally make the error or not, you've done everything you can do. But if you had, or if you made an error, then which one of these two errors would you rather commit? If you knew you were going to commit one, intentionally or not, which one of these two errors would you be willing to commit? I don't want you to answer out loud because there is an answer to this question. But before we come up with the answer together, I want to go through this one more time. But we're going to take a look at it from a different point of view. In our American judicial system, when somebody goes to court, maybe you've been to court in front of a jury, I don't know, but the assumption that is given to the jury, and if you put yourself into the jury seat, is the defendant is always assumed innocent. And it is the prosecuting's job to sway the jury or to convince the jury that you're guilty of a crime or that a crime has been committed by somebody. So there's only two things that can happen. That the defendant is innocent or that the defendant is guilty. There is no two ways around this. And you have to make the decision. All right? So far, so good? So the question is if you go, just like on hypothesis testing, statistically speaking, remember I said we always assume the null is true. So the question now is, what is it going to get, or what is it going to take for you to move from the null hypothesis to the alternative hypothesis? Not that you want to move, but if you had to, what is it going to take to get you to go from here to here? Now here's the lovely thing. The true state of nature, one person knows the true state of nature, and that is the defendant. That defendant either did or did not do what he is allegedly alleged to have done or not. Allegedly alleged to. Woo! Okay? But I think you get my point, right? The defendant knows. Now you go to a jailhouse and I'm sure that every one of them people will sit there and say, hey, I didn't do anything. I was just victimized by the judicial system. And there may be some truth to that. I don't know. But the defendant knows. That's the true state of nature. So remember, the whole process is in our statistical hypothesis testing, if we were to make an error, which one would we like to know that we have made if we had to choose between one or the other? Okay? So let's just kind of note, if the defendant really is innocent and you, the jury, come back and say we find him innocent, no problem. But if the defendant is guilty and you come back and say he's guilty, then hey, good job. Again, nothing to worry about. But the type 1 error says that you moved from here to here when this is true. So notice that the type 1 error says you come back and find the defendant guilty when in fact the defendant is innocent. So what does that mean? That means that you are going to send an innocent man to the gas chamber. Now that's not a great thing. None of these errors are good errors to commit. I'm just asking, if you had to commit one, which one, if you committed, can you live with? This error here, you come back and say the defendant is innocent when in fact he committed the crime, then you've committed this type of error. Well, this type of error says you've let a guilty man go free. So now you have to ask this question. If you are going to make one of these two errors, whether you want to or not, and it happens, which one can you live with? Can you live with can you live with sending an innocent man to the gas chamber? Or can you live with letting a guilty man go free? Now, knowing that both of these are not the appropriate one, it's an error, you don't want to commit it, but if you had to commit one of these errors, which one are you willing to do? Are you willing to look a man in the face and say, I'm sending you to the gas chamber, or are you willing to look a man in the face and say, you're free to go? And you're going to be able to sleep at night. I think we can all agree that if we had to commit one of these two types of errors, the one that we would be willing to commit would be the type 2 error, no matter what. I don't think any of us with a clear conscience can send an innocent man to the gas chamber. All right, so now the question that I would like to take a look at while we're on this slide then is, if I'm going to, and I know I might commit an error, whether intentionally or not, then hopefully I have a way to control for one of these types of errors. All right? So the idea is, if we start and assume that the null hypothesis is true, and this is the type of error that we do not want to commit, then that means that when I move from here to here, wouldn't it make sense that if I'm going to make this error, then I would like the probability of committing that error to be small. If I accidentally commit this type 1 error, because that type 1 error comes from me moving from the null hypothesis to the alternative hypothesis, then the probability when I make this transition from the null to the alternative, making that transition, if I'm going to oops, then maybe I should make the probability of that occurring small. So some acceptable levels for the alpha probability are usually 0.1, 0.05, and 0.01. That's why when I had you choose your alpha level, I had you choose one of those three. I'm not saying that's what they have to be. I'm saying that these are the three popular ones. There's nothing stopping you from having an alpha level of 0.129. There's nothing stopping you from having an alpha level of 0.2257. There's nothing stopping you from having an alpha level of 0.4. But the popular ones are 0.1, 10% probability you commit the type 1 error, 0.05, 5% probability you commit that error, or 0.01 or a 1% probability of committing that type of error. Okay? So the type 1 error is an error that we can control when we make our decision-making process.